we move to another rundown. So this will be the last session, the last presenter for this session before we have the break. Pak Leonardo, and then with the co-authors Pak Randy and Pak James Purnama, with the title Distance Measurement Decision Making Backend System Using NodeJS. So it's the similar with the backend system using NodeJS, but different case study, I think. So please, Pak Leo, time is yours.
Dr. Mala. Good afternoon again, lecturers, seniors, and my fellow friends. It is a great honor for me to be able to present here. My topic will be about the distance measurement decision-making backend system using Node.js. So just a brief background whom this system is for is that Kunyaku is a startup business which intends to tackle problems in the catering industry. And basically the main business model here is that we'd like to white label micro catering vendors' product and sell it using our platform. Now, because we might sell the same menu shared between multiple vendors, the vendor selection has to be made to which best vendor can have the particular menu or order to the customer. And this decision is selected based on distance, vendor order capacity, as well as price margin. The approach here is how we can actually select these vendors. We can actually select them by hiring a staff to decide manually. Hence, this will involve extra costs as we need to hire more people, as well as human biases. So the staff might favor one vendor over another over several reasons. Might be family reasons, or they just like these vendors, or there is an additional under the table deal or whatsoever. So we do not want this to happen. Therefore, we'd like to use technology to ensure a fair and square decision making. And even though the initial cost is higher, but this will be a one-time expense. It will be a one-time long-term investment that won't need occurrence in sort of technological investment. The research problem here is that there is no current existent e-commerce platforms which can handle our sort of need of MCDM for the catering business. MCDM in short, it means multi-criteria decision making. The objective here is to develop a backend system which handles MCDM while minimizing the development costs. The research question here is that how can Kunyaku develop a backend solution to accommodate finding the most suitable vendor through multiple parameters? Here, the hypothesis is that we can use AHP or analytic hierarchy process algorithm to develop a decision-making feature in the backend system. The methodology overall, in terms of the group-wise, this business involves a big group. So we have business requirement analysis, system requirement evaluation, and data structure design, finally developing the system and testing and evaluating the product. The system development itself in the software side will be made using a hybrid of Scrum and Agile. And included here will be the study of the analysis between e-commerce platform solutions. And another FGD session will be held at last to evaluate the system. So this is what the group has done. The framework used in the backend system will be Node.js, MySQL database, hybrid of Agile and Scrum in terms of development framework, REST API, JMeter, Jest, JWT, Haversine formula. Now, Haversine formula is very unique because we can simply think about calculating distance between 2 points and imagine a 2D plane where we can easily take Euclidean distance to find the distance, but technically we don't live in a 2D plane in this planet. So the Earth is a sphere, and therefore we need a different formula which uses the great circle distance to find out the distance between 2 points. And Haversine formula is just one of these solutions to approach this. And we use Google Maps Distance Matrix API, although due to financial resources, the limitation of financial resources, we're not able to use this as a deployment solution. So we just use Google Maps Distance Matrix API to test the system. And of course, analytic hierarchy process to to allow us to perform the multi-criteria decision making. Or at least that's the hypothesis for now. Here is the system analysis, and based on a couple of tests, why do we choose WooCommerce and Squarespace? Because WooCommerce makes the most and Squarespace second in terms of e-commerce solution in the market. So ready-to-use e-commerce solution is currently handled by WooCommerce in majority, and second is ranked by Squarespace. Here, we can see that these two approaches are not suitable for the multi-criteria decision-making. And here in the custom NodeJS backend solution, we have to custom write our own code. And in terms of cost, the Node.js would just cost around $5 per month because we got to pay for the VPS, while the others cost $150 per year per site, or in Squarespace term is $18 per month, or $216 per year. The system design, here is our very brief system design. It's very short, and the MCDM backend system will actually be involved here. Change order status and assign the vendor chosen after the order has been accepted by the particular order has been checked out. So this is our Ahp design. Here we have the criterions, which is the capacity, distance, and the sell price or margin profit for us. We made that the least priority, but that has to play a role. While order capacity has to be the majority of the weight because the vendor, because they're micro caterers, they will have maximum capacity in how many orders they can actually handle per day. And the distance itself, because distance is a big role in terms of logistical speaking. So we would like that to be two major roles, while finally we would like the margin profit to be our last priority here. And as you can see here, it will be judged based on the distance. We have the same menu here to be accommodated to 4 vendors, and these will be calculated again using the Ahp algorithm to determine which vendor suits the most to handle the order. As shown on this flowchart, when an order item is being checked out, it will check for the order items and then the vendor for the particular menu and calculate the decision parameters for each, and then forms the result matrix, multiply the result matrix by the relative matrix, which is the criterion, the weights, as we shown before. It's right here, the capacity, distance, and the sell price. And the store result will be recommended as the results will be stored as the recommended vendors, and the highest score will be the first chosen vendor. Unless that particular vendor rejects the order, then the second highest vendor would be chosen. However, here we tested Google Maps distance matrix API and Haversign formula, inputting the 2 distance into the Ahp, but this test does not have anything to do with the Ahp. This is purely just distance measuring. We would like to see, because one thing for sure is that despite calculating the great circle distance of the planet Earth, of 2 points between this planet, Haversign formula disregards any obstacles or any sort of hindrance between these 2 points. Whereas Google Maps, for sure, we know that it calculates roads, bridges, and obstacles, roadblocks, and everything as a weight, which contributes the factor of their decision making and finding the best way for us to reach a certain point. Therefore, we use Google Maps as a control here. We can see that in shorter distances, there is just less than 40% of error. But as soon as we see the greater the number actually increases. So with the Haversign result of 16 kilometer, and Google gives us this distance of 32.1 kilometers, which gives us a crazy number of 49%. So simply to say that the Haversign formula will not be able to sustain in the long-term use, as it will give a lot of errors in the result of the Ahp process. However, in conclusion, the Ahp, of course, it can be used to solve the MCDM or multi-criteria decision-making problem, and Google Maps Distance Matrix API will always be the one to give more reliable long-term result. As I mentioned before, the Haversign formula does not take any obstacle into account. this marks the end of my presentation. Thank you.
Okay, thank you, Pak Leonardo. So is there any question from the audience? So it's related to the topic kunyaku with the Pak Ko already presented before, yeah. It's the similar topics but different angle, because here it's more to the backend system. So is there any question from the audience? Okay, while waiting, I would like to ask about the algorithm itself, about the AHP, about AHP, hierarchical, analytical hierarchical. Uh, how did you finally choose this algorithm, and why is it suitable with your case study? Because there is a weight, yeah, weight as you already in the previous slides. How is it going?
So we did some literature review about different kinds of algorithm, but there was a case where we met a paper during my thesis studies about finding the best, also vendor, but this is a different angle study. It tries to find this best supplier in finding different cases. And the literature review specifically says the AHP will be the most scalable process, because it does not only take objective criteria, but it also takes subjective criteria in terms of the decision making. So this is, in terms of food, we can say that there is a lot of subjectivity in terms of taste and preferences. Therefore, we choose AHP because it is suitable for this kind of accommodation.
All right, thank you for the answer. Are there any other questions from the audience? Oh, there's questions. Instead of Node.js, is there any other alternative for the platform that you use?
Yes, actually, we did a literature review with Python and PHP, and the result was shown that Node.js, if I may, I don't think that's necessary. Node.js gives the best result in terms of performance in comparison with PHP and Python. And why PHP and Python? Because Node.js is also one of the scripting languages. We compare the scripting languages against the two other scripting languages as well, to be fair.
Okay, so you compare Node.js with Python and PHP.
Yes.
Right, okay. Okay, thank you. Are there any other questions from the floor, from the audience? Okay, so I would like to have a question from the you did comparison between the Google one, yeah,
yep.
and Haversign.
Yep.
How is your result highlighted? So it seems that yeah, this one you mentioned that Haversign is better, or how is it?
So basically, the sample size on the left is just an example of 150 samples we performed to test against the Haversign formula and Google Maps distance matrix API. And we can see here that the shortest distance here with 1.4 kilometers gives 80% margin error. Now, sorry, error percentage. Therefore, how can this be possible? We can actually highlight this by thinking this analogy. We have point A and point B. In between point A and point B, there is a long river that stretches, and there is no bridge until the next, let's say, 8 kilometers. Now, the Haversign formula disregards the river and immediately calculates the distance between these 2 points, which gives us a very, very short distance. However, in Google Maps, it uses this different sort of approach where it it calculates the point A and point B as the main points, as the final destination, and it uses turn points as edges, while the routes to the edges are its vertices. So it calculates all of these vertices until it reaches point B, which takes us to all the way to the bridge and turning back to point B. So this is how not reliable Habermas formula is in terms of logistical speaking.
Okay, so the Google one is more reality then, yeah?
Yes.
All right. So, yeah, I continue my question. So based on the, so you have several source coordinate, yeah, with the,
Yes.
so the source of coordinate, it's like the vendors, the catering vendors, and then the destination coordinate will be the customer, or
Yes.
how is it in the real case?
Well, we can actually think this about interchangeably, because we just take like 150 random coordinate points, and then we just play it around with 150 of them.
Oh, okay, okay.
But
So
in the real business, we can actually think this about think this as the customer and the vendor. It's true.
all right, but this data is not yet implemented as the real vendor or real customer.
No, but these are randomly generated, but of course selected, so we can see some ridiculous points, like in the roads nearby the farm or the field. We do not use those as what's it called, a reference for this. We treat that as an outlier, a sample, and then we don't use that sample.
Okay, okay, thank you, understood. Yeah, great.